Hello everyone, I am Ashutosh Rai, PhD scholar at IIT Mandi. Here I am going to present a concept of vehicle-to-vehicle power transfer in case of input supply failure scenario. The fundamental architecture of wireless charging consists of a transmitting and receiving coil which enable power transfer through electromagnetic induction. Now, what if the power supply fails and there is an urgent need to charge an EV? So, another fully charged EV can be used as a power source to charge it. The available solution to this problem are like use of an external DC-DC converter linking the energy storage of both EVs or use of an intermediate coil spanning the receiver of both the EVs. Both these solutions require substantial hardware modification, which is not a cost-effective approach for vehicle-to-vehicle power transfer for case of two wireless EVs. The proposed solution just requires a high-frequency cable to connect the transmitters of both EVs, with both EVs parked in their respective parking slots. Now, when there is a fault, both the primary bridges are bypassed and wireless coupler assembly of both EVs are cascaded to enable power flow from one EV to another. When the two transmitters are connected, the system resembles a dual active bridge with two resonant tanks connected back to back. Before starting power transfer, it is important to analyze the current response with the switching frequency. At the resonant frequency, the coil currents spike to a large value as the input impedance drops sharply, making the operation unsafe in the close vicinity of resonant frequency. Therefore, a safe frequency range where the currents stay within their rated limits must be identified for each transmitter and receiver pair. Once this frequency is identified, the converter's switching frequency is set accordingly and the power transfer is controlled using standard phase shift control methods. Now we will proceed with simulation validation. From both the current responses, the switching frequency identified was 91 kHz. In these results, initially power flows from V1 to V2, but at 0.02 second, the command for power reversal is given. This can be clearly seen as DC charging currents reverse their direction. These are the waveform for inverter voltage and current for the receivers at both the EV side. We can see in the zoom in portion that after 0.02 second, the direction of currents IS1 and IS2 are reversed compared to before 0.02 second. This is the consolidated experiment setup photograph. Here is my laboratory setup where the experimental validation was carried out. The experiment follows the same approach as simulation. The hardware results for both V1 to V2 and V2 to V1 power transfer are presented here. To conclude, with a high-frequency cable and basic bilateral communication between two EVs, charging can be achieved during a supply failure without major hardware modifications. Finally, I thank IES SYPA program for the financial support. Thanks for watching the video.